Now let's talk a little bit about osmosis. So osmosis is a physical process where solvents, typically water, move through a semipermeable membrane from an area of low concentration of dissolved substances to an area of high concentration of dissolved substances until the concentration is evenly distributed on both sides of the membrane. So let's look at it right here. Suppose we have compartment A here, here we have compartment B. This could be intracellular and extracellular, who cares? Then we have a membrane, and this membrane is actually what determines the concept of osmosis, right? You cannot have osmosis without a membrane in the context of cells. So here it is a semi-permeable membrane. Suppose we have 10 millimoles of glucose in compartment A and 2 millimoles of glucose in compartment B. By a simple diffusion, it will go from high to low concentration. But because this is semi-permeable, meaning it is impermeable for everything besides water. Typically in biological systems, it's only permeable for water. So glucose cannot move through and out of this membrane, only water. So because water is less in compartment A here, water will go from high concentration to low concentration. So from compartment B to A. Okay, so this is due to osmosis. This is due to osmosis. Okay, so for example, if you have solution of sodium chloride, so it could be 10 millimoles of sodium chloride and 2 millimoles of sodium chloride in compartment B. Sodium chloride would diffuse, so water would then diffuse with high salt concentration. So in the solution with higher osmolarity, so in compartment A we have higher osmolarity, so it means that it will diffuse to where it is from lower to higher osmolarity. So osmolarity referring to the number of moles of osmotically active particles per liter of solution. And osmotically active particles are particles that are not water. Okay, so of course the osmolarity is higher in compartment A compared to compartment B. Then we also have the concept of osmotic pressure. What is osmotic pressure? Well, suppose you have a beaker here. You have a beaker with water. So the pressure water exerts on the beaker is osmotic pressure. Osmotic pressure. And the same thing, if you could have, for example, you could have a blood vessel, you could have a cell membrane. So this is a blood vessel. You could also have a cell membrane here, so on and so forth. So for example, with the blood vessel here, the higher the concentration of particles that are not water in solution, the greater the osmotic pressure in the solution is, and this will lead to the greater diffusion of water into the vessel. Okay, now let's do this task here. What are the osmolar concentration of 1 millimoles of sodium chloride, 1 millimole of this, 1 millimole of this, 5 millimole of glucose, and 1 millimole of sodium 9 proteinate? Well, here we know 1 millimoles of, for example, sodium chloride is the same as 0.001 moles of sodium chloride. We also know sodium chloride will dissociate to 2 mole particles. So this gives us an osmolar concentration of 0.02 osmoles per liter. And similarly, we can do it for all the other things right here. Okay? Now they ask you, a cell has the following intracellular concentration for all these different things here. What is the charge on the protein? So this is the protein. Explain the principle of electron neutrality. So we can count the total amount of negative charge to be minus 65 plus 6 times minus 2. So minus 65 is from chloride, and 6 times minus 2 is from here, giving us a total negative charge of minus 77. Total amount of positive charge is from potassium, 122, plus 9 from sodium, giving a total positive charge of 131. So the total charge here is 131 minus 77, giving us a total charge of 54. But we know that there is a law called electron neutrality, meaning that the total amount of positive and negative charge must equalize each other. So PRN minus must equalize this charge. It must have minus 55. And this minus 55 charge needs to be distributed on its concentration, right? So this will give us the total charge of one of these proteins. So this is minus 4.5. Now they ask you, in an experiment, the cell from part C is to be suspended in an isoosmotic solution of sodium chloride. The molar mass of sodium chloride is 58 grams per mole. The temperature is 37 degrees Celsius and the pH is approximately 7. How much sodium chloride should be weighed to prepare 5 milliliters of isoosmotic sodium chloride? First thing we do is calculate the total osmolarity based on the concentrations provided in C. Okay, so the total osmolarity is given here. Now we also know that sodium chloride dissociates into 2 particles into water, so we divide the total osmolarity by 2. Then we determine the amount of substance needed for the solution. Okay, so this is the total osmolarity divided by 2 here. So the concentration times the volume, right? And the volume is given to be 5 milliliters. So this is the amount of substance needed for the solution. And then to calculate the mass of sodium chloride required using its molar mass, we simply take the molar mass times the amount of substance to give us the final mass of sodium chloride. So 0.031 grams of sodium chloride should be weighed to prepare 5 milliliters of isoosmotic sodium chloride solution. Now let's also understand what an ideal semi-permeable membrane is. So this is a membrane that is only permeable for water and impermeable to all dissolved substances. Now, to define the terms for hypertonic, hypotonic, and isotonic, I want you to understand that for hypertonic, so here to the right, it's a solution with a higher concentration of solute compared to another solution. So when a cell is placed in a hypertonic solution, water will move out of this cell, causing it to shrink or shrivel due to osmosis. Hypotonic is a solution with a low concentration of solute compared to another solution. So when a cell is placed in a hypertonic solution, water will move into the cell, causing it to swell or burst due to osmosis. And isotonic is a solution with the same concentration of solute as another solution. So when a cell is placed in an isotonic solution, there is no net movement of water and the cell maintains its normal shape and size. Okay,